Hello, welcome to new video of Revitasium. You might recall about limits from pre-calculus. Here we are going to demonstrate how we are going to apply limits in geometry of a family. You are going to see how application of limits is going to push the limits of Revit. If we search on Google PPR elbow, you're going to see lots of PPR elbow fittings. They come in different shapes. Some elbows look like this, whereas others look like this. The one which we are going to talk about in this video is this one. Here sizes from DN20 to DN40 have a geometry like this, whereas sizes from DN50 to 160 look like this. Obviously, these two geometries are not the same, and the way to make these geometries aren't the same. So if we have to make a single family that is accurate to both shapes and has all the sizes, it's not going to be possible. Or is it? Well, let's have a deeper look at what parameter values makes them different. So if we look at the table, it's this dimension Z that is responsible for two different shapes. DN sizes from 20 to 40, Z value is big enough that these two extrusions don't meet with each other. And the turning part is complete circle revolving 90 degrees. Whereas DN sizes from 50 to 160, this dimension Z has a value which is smaller, which results in overlap of these two extrusions. Hence, the revolving part isn't the complete circle. Now we are going to see how limits can be useful in this particular case, which can be applied to get both of the shapes using one common geometry. So if we look at the sizes from 50 to 160, the overlap of extrusions is distance dimension Z from the center of circle. So this line becomes the chord, and the distance of chord from the center of circle can be calculated using the formula. So what we are going to actually do is to calculate this dimension Z2 when limit is applied to chord length. We are going to make this chord length as small as possible, since Revit does not accept the sketch line of geometry less than 0.8 mm. We are going to find out distance of this chord from the center of circle Z2 when its length is just 1 mm. Limiting chord length to 1 mm. Squaring both sides. Rearranging the equation. Writing R as OD by 2 and D as Z2. After rearranging, we get this. Merge formula in the formula bar of family parameter calculations. Apply if formula for sizes 20 to 40 to calculate Z2, and that's it. Using this formula, we can see that now we can give any value of DN from the table, and it makes both shapes by one single geometry. Hope you find it useful. Don't forget to like, share, and subscribe.